The graph of the function f is shown below. If g of the function given by g of x equals f of x, what is the value of g of 0?
Okay, let's start by deriving g of x, so g prime of x. Now this right here is chain rule. So you derive the outside, keep the inside f of x, and then you derive the inside. Are you writing with me? And then it says to find g of 0. So when I plug in the 0, it's going to look like f prime of f of 0 times f prime of 0. So the first thing is f of 0. Now, f of 0 is a point. So when x equals 0, my y value is what? 3. And because I'm thinking ahead, I want to do f prime of 0. That means, what is the slope of this line right here? It is positive. Someone do rise over run. 2. Very good. And then so we have f prime of 3 times f prime of 0 was 2. Now I need to find what is the slope at 3. So 3 is right here. I need to figure out what is my rise over run right here. It is negative. It'll be a fraction. Negative 2/3. So we have negative 2/3 times the 2 is going to give us negative 1/4. And that is our final answer. Questions on that one? So if it's a prime, it means find the slope of that specific line. Okay, number 11, Caitlin, let's read.
Functions of f and g are differentiable for all x, f of g of x equals x, and g of f of x equals x. If f of 1 equals 2 and f prime of 1 equals 5, what are the values of g of 2 and g prime of 2?
These two statements right here is just to say they're inverses. So let's see if y'all remember the inverse function. So we have g prime of 2 is equal to 1 over, what was it? F prime of g of 2. That should be memorized. So on this one, g of 2 is nowhere to be found. So it says, what are the values of g of 2? So let's see. Because they're inverses, I could say this is equivalent to g of 2 is equal to 1. So then when I plug it in here, I get 1 over f prime of 1. And is f prime of 1 given to us? Right here, so it'll be 1/5. So do remember or memorize the inverse derivative. Okay, the next one technically should be number 12. It's 11.5. G of 2 and g prime of 2. Well, g prime of 2 is 1/5. G of 2 is 1. Lauren, let's read number 11.5 with the conditions.
For any function of f, which of the following statements must be true? If f is continuous at x equals c, then the limit as x approaches c of f of x equals f of c. If f is defined at x equals c, then the limit as x approaches c of f of f equals f of c. If f is differentiable at x equals c, then the limit as x approaches c is f of x equals f of c.
Okay, I want to look at the very last one. When something is differentiable, we know it's automatically what? Continuous. And because it is continuous, we have the following that must be true. So this one is true. I'm going to put a check mark. And then for part B, I want to actually show you this with the picture. It's saying it is defined that we have a number at C. Here's C. Then does that guarantee that it's going to have the same limit as that value? So let's say I have a picture like this. Does that mean this limit is equivalent to that point? No. So this is going to be no. And if something is continuous at C, so I have a continuous function at C, does that mean my limit is reaching that point as well? Yes, it is. True. So we know 1 and 3 must be true. Okay, let's go on to number 12. Okay, Nicholas, let's read number 12 out loud, please.
The table below gives selected values for differentiable function f. In which of the following intervals must there be a number c such that f prime of c equals 1/2?
So this one's going to be mean value theorem. It's saying, is there a slope of 1/2 between the two values? So looking at these, do y'all see anywhere where it'll actually be y2 minus y1 over x2 minus x1 has to be 1/2? Will it be between these two? Between these two? Look at this one though. The difference between these two are 2, right? Difference between 4 and 8 is how many? 4 and 8? 4. What is 2 over 4? It is 1/2. So we know f of 8 minus f of 4 over 8 minus 4 is equal to, we know f of 8 is 2, minus f of 4 is 0 over 4. That does give me 1/2. And that will be between 4 to 8. And of course, if you get stuck, you can look at the answer choices and kind of compare where the slope is going to be 1/2. Okay, Danielle, let's read part number 13.
Let f be defined by this function f of x equals 2x cubed minus 3x squared minus 12x plus 18. On which of the following intervals of the graph of f both decreasing and concave up?
So decreasing means f prime of x is less than 0. Concave up means f double prime is greater than 0. So I need to derive this twice. So my first derivative, 6x how many? Squared, and then minus how many? 6x, and then minus 12. And I need to set this equal to 0 as well as factor my GCF. And when I do, I'm going to get, what two numbers will satisfy this factor? Good, -2 and +1. Okay? So that means our critical numbers are at 2 and -1. So let's test our number line. Here's -1, here's 2. It's going to go on forever. And I need to test some points. I think testing 0 will be clever. Maybe 3 is fine. And then maybe -2. And we're testing it into this factor right here. So when I plug in -2 to 6, that 6 is always positive. When I plug in -2 in the second one, is it a positive or negative? What was that? Negative. When I plug in negative to the third factor, I get negative. So that's going to give me positive. The graph is going up. Okay, let's test the 0 and 3 on your own. Is the graph going up or down? It's going down. And the last one, the graph is going up. So right now, the graph is going down when f prime is less than 1. So I want to find another derivative. So we have f double prime. And I'm going to give you a little pointer on this one. You can derive the initial, or you can derive the second one by leaving the 6 alone. 2x minus 1. And when I set this equal to 0, there's only one possible point of inflection. At this point, x equals 1/2. So my x equals 1/2 is right here. And I would test 0 and 1. When I test my 0, 6 is already positive. Plugging in the 0, that's going to give me negative. So is this concave up or down? Down. And then the next one is going to give me positive, concave up. So that means our concave up is this piece. So I need to find the intersection between this interval to the next interval. So which one is the intersection? What repeated between those two? 1/2 to 2. All right, Nate, let's read number 14.
The graph of f prime, the derivative of the function f is shown below.
Okay, if there is a derivative, is it continuous? Yep, so we know this is true. So let's analyze what's happening. We know we have a negative value and positive value. It is f prime of x. And I want to kind of look and see if it's concave up or down. So when f prime is going from positive to negative, there's a relative max. But this one's going from negative to positive, so this must be a relative what? Relative min, my f of x. So we know we have a relative min. And because it's relative min, is it a concave up or down? Concave up. Is the graph increasing? Always increasing? It's increasing here, it's decreasing here, so we know this is not true. So it'll be 1 and 3. Are we good with that one? Okay, number 15, Kira, let's read.
Given that 7x minus tangent of y equals 9, what is dy over dx in terms of y?
Okay, so when it says dy over dx in terms of y means, your final equation is going to have dy over dx by itself and something something y. So let's go ahead and derive. What is the derivative of 7x? Nicholas, are you with me? Right with me. 7? What was the derivative of secant, or tangent? Secant squared. So we have secant squared of x, or y I mean. Because I'm deriving something with the y, what do I need? dy over dx. And the constant is 0. So let's do two things at the same time. I'm going to leave this alone. I'm going to move the 7 over by subtracting. That part is algebra. And divide it by the coefficient of dy over dx. Do we see double negatives here? Yeah? What can I do with the double negative? Get rid of it. But then, since secant squared is on the bottom, what's the reciprocal of secant squared? Cosine squared of y.
Why wouldn't you add secant?
What's that?
Why wouldn't you add secant?
Because secant was stuck with dy over dx.
But it's still negative.
What do you mean?
It's minus secant.
Okay, so let me do the algebra on this one. If I have 2 minus 3, x equals 0, I would subtract 2, which I subtracted 7. I would divide it by negative 3, which I divided by negative that value. Okay? So I would say this is correct, but if it were to be a multiple choice, they might even simplify further with the reciprocal. Okay, let's go on to number 16. For this one, I don't see a point of reading them. What rule are we using to derive this one? Chain rule. So chain rule states, bring the first one out. So f prime of x, bring it out. Keep the inside. I hope everyone's writing with me. And then we derive the inside. What is the derivative of that inside? 2x. And then we plug in the 1. So 4, 1 squared is still 1. And then 2 times 1 is still 2. So that's going to give us 4. And what is negative 2 all to the power of 3? What kind of 8?
No.
Negative 8 times 2. And that'll give us negative 64. For 17 is another chain rule, and I'm going to rewrite this. Let's rewrite this one as cosine of 4x all cubed. So we bring the 3 down, keep the inside as it is. And in the inside, there's two things happening. Cosine happens first, and then 4x. What is the derivative of cosine? Negative sign, and you keep the next inside alone. And then multiply by the inside, which is 4.
Shouldn't the cosine 4x be squared?
Cosine 4x be squared. Thank you. That is correct. Good catch. So now let's look at all the coefficients. When I go ahead and put them together, that gives me negative 12. Cosine squared of 4x, I'm just writing it the way the calculus likes it. Sine of 4x. And that is in what option? Letter how many? B. For number 18, how many times are we deriving? Twice? Let's find the first derivative. What is the derivative of cosine? So I'm just going to say positive 3 sine of 2x. And then derive that 2x, which is 2. And let's simplify this. Our coefficients together is 6 sine of 2x. Now let's find the second derivative of that. What is the derivative of sine? Cosine, so 6 cosine. You keep the inside and multiply by the derivative. And that, when I multiply 6 and 2, it's going to give me 12. And the only one that has positive 12 is B.